Question 25. How many 4-digit numbers have the following property? For each of its digits, when this digit is deleted, the resulting 3-digit number is a factor of the original number. We're looking for that each. So every time you take away one of those digits, it has to be a 3-digit number that's a factor of the original number. Now, this is such an innocent looking question, but to pick question 25, you know it's going to be involved. And these actually, I'm not a fan of ones that have got different digits in them that we've got to create, but let me show you how I did it. Okay, so I called the 4-digit number A, B, C, D. Now, this is not typically how we use letters. A is 1 digit, B is 1 digit, C is 1 digit, and D is 1 digit. D is in the ones column, the C is in the tens column, B is in the hundreds column, A is in the thousands column. Now, I'm going to use the old-fashioned way of having a 0 on a keyboard, and that is not the letter O. We are just looking at a 0. So all the different permutations. When a digit is deleted, then you can have BCD, ACD, ABD, and ABC. And these must all be a factor of ABCD, where A, B, C, and D are individual digits. So let's look at the ABC first. ABCD can be made up of ABC here, multiplied by 10, which puts it ABC with a 0, and then we have to add the D as well. So this describes ABCD. And because ABC is a factor of ABCD, which is this, then if we take a factor of ABC out, we have 10 plus D divided by ABC, has to all be an integer, so therefore this has to be an integer, but this can't be a number that's greater than 1 unless D is 0. So we've got a helping hand, we know that D is 0. Taking that information forward, we're going to go and look at ABD now. But we already know some key information about these two numbers. We know that ABC 0 divided by AB 0, because D is 0. So what does ABC 0 look like? Well, it's AB 0 because we're looking at it as a 100 here. Multiplied by 10 puts it in the right place value. Then we're adding C0. So we've got this AB 0, 0. That's what this is. And then we're adding this bit, which is C0. Again, we need to take out a factor of AB0. And again, we've got C0, AB0, which again are numbers and not A multiplied by B multiplied by 0. And again, in the same way as the logic here, this C is going to be 0 as well. Down here, what we've got, AB 0, 0, we're now looking at ACD. So we can look at A10 multiplied by A0, 0, which gives us A0, 0, 0. And then we are adding B0, 0. So this can be written like this. So B divided by A0, 0, we know that B must be a multiple of A. So the possibilities we've got for A's and B's, 1, 2, 2, 4, 3, 6, 4, 8. Of course, it can be the same actually. So B could be 1. So it can be either this, or B equals 2, or B equals 3, B equals 4, B can't be equal. Oh, in fact, B can be equal to 5. C can be equal. So we can have, although that's where that one stops, C can be, A can be 6, B can be 6, etc., all the way up to A equals 9 and B equals 9. So where the final one up here, BCD, BCD, B00 must also be a factor. So therefore, ABCD equals, we know AB00 now, and that can be written as A000 add B00, so A1000, B100. We take out that factor of B00, and we're left with this expression here. We cancel them out, so therefore we know that A0 has to be a multiple of B. For B to be a multiple of A and a factor of 10 multiplied by A, B must be A, 2A, 5A, or 10A. 10A is more than one digit, so we can't have 10A. So looking at each of these three in turn, when we put B equals A, we get AB00 equals AA. So therefore we've got all the numbers from 1,100, 2,200, 3,300, all the way up to 9,900, and there are 9 possibilities. When B equals 2A, we get 1200, 2400, 36, and 4800. Can't be 5 because then the 2A would be 10, 4 possibilities. And then if B equals 5A, we get 1500, which is 1 possibility. We add those 3 together and we get 14 possibilities, and therefore our answer is C.